All right, this lesson is for Unit 3, Lesson 4, which will be about regular polygons. We're skipping over Unit 3, Lesson 3 this year. It's something we kind of already talked about, so for time, we're cutting it, and that's why we're going from Lesson 2 to Lesson 4, just if you're confused about that. We'll be talking about what a regular polygon means and how to talk about its interior and exterior angles, as well as finding the area of a regular polygon. A regular polygon, okay, as opposed to just a polygon, means a polygon where all the sides are equal and all the angles are equal. So this is an example of a regular pentagon. All the sides are the same and all the angles are also the same. Okay, this is a pentagon, but the sides are different, the angles are different, so we call it irregular in that case. We'll be talking about the interior and exterior angles of polygons a lot. We kind of mentioned this last lesson. An exterior angle, remember, is you take a side and you extend it, and then you take the angle back to the polygon. Okay, extend a side, back to the polygon. Extend a side, back to the polygon. It turns out, and this is a theorem, for any polygon, the exterior angles will add up to 360 degrees. Really, for any convex polygon. No matter what. So if you take every single angle and you extend all the sides, extending a side only once, okay, kind of like we've done here. If you add all those angles, they will always add to 360 degrees. Doesn't matter how many sides, doesn't matter how big or small, always 360. And so furthermore, if we know that a polygon is regular, then we know everything is the same all the way around. And so if a regular polygon has n sides, then every exterior angle must be 360 divided by n, right? So if we go back to this picture, right, this is a regular hexagon. Well, 360 divided by 6 is 60. Okay, each of these must be 60 degrees. It has to add to 360, and they're all the same, so we can simply divide 360 by the number of sides, which is also the number of exterior angles, because you're extending each side once. So that is an important little formula just to know when you're looking for exterior angles of a regular polygon. And we can ask you, what are the exterior angles of a regular octagon? So first of all, you just need to know an octagon has 8 sides. And so you would simply do 360 divided by 8, which is 45 degrees. And that's it. Each exterior angle is 45 degrees. Again, an octagon, a regular octagon would look like this, like a stop sign. Each of these, when you extend it out, okay, has to be 45 degrees. But this is the key word, right? It has to say regular, or you can't assume that they're all the same. Knowing this, we can go a little bit further now, and we can talk about the interior angles. Okay, if we think about it, right, extending a side, going back to the polygon. Well, we extended a side, that's a straight line. And so the exterior angle plus the interior angle must add to 180, always. And so for a regular polygon, we just said every exterior angle has to be 360 divided by n. Well, we can also figure out the interior angle by simply taking that, whatever we get, away from 180. Right, so going back to the example of the hexagon for a minute, we knew every exterior angle was 60. Well, that means every interior angle must be 120. So the easiest way to figure out an interior angle a lot of times is just to figure out one of the exterior angles, as long as the polygon is regular. Okay, so first question here, what's the interior angle of a regular octagon? Well, we knew from before that 360 divided by 8 was 45, right? That's an exterior angle. So we can simply do 180 minus 45 and get 135. Okay, we actually just did hexagon, but again, you would do 360 divided by 6. I got ahead of myself, apologies. That's an exterior angle. You can abbreviate. And so we simply do, again, 180 minus 60, and that gives us 120, and these are each interior angle. Simple as that. All right, the other part of the lesson for today is how to find the area of a regular polygon, and I will first of all derive this formula for you. Okay, so I'm using a pentagon, but we could use any shape for this. What we're going to think about is breaking this shape into triangles. Okay, so I'm going to put a dot right in the very center of the figure. I'm not drawing that very well, but imagine that was a straight line to give me a triangle. Okay, so we end up with 5 triangles that are all the same because it is a regular polygon. Now, I don't know how to find the area of the big shape, but I do know the area of a triangle is 1/2 base times height. So let's see, if I knew this side, that would be the base of the triangle. So let's just say we know what that length is. I'm just going to call it x. Okay, and then we also would need to know the height of the triangle. So let's just say we knew what that was. I'm going to call this h. We'll give this another name in a minute, but for now we'll call it h. Okay, so the area of this triangle would be 1/2 x times h. But then think about it. There are really 5 identical triangles. So the area of the pentagon would be 5 times that. And another way to express that, right, if we do 5 times x, well, x is a length of a side. So 5 times x would be finding all the sides, better known as the perimeter. So we could even simplify this formula. If we let P equal the perimeter, we could say it is 1/2 times, right, 5 times x would just be the perimeter times the height of that triangle. Now we're going to give this another name. I called it height so we could see, because we're used to using triangles. But what we're usually going to call this distance is called the apothem, which is the distance from the center of a polygon to its edge. Distance measured from the center directly to the side at a right angle. And it's from here that we get the formula, which will be on the next slide. Now, you don't need to derive this formula again. All right, again, I just don't ever want to give you a formula and make you think that it falls out of the sky. This is the formula that you need to take away from that. The area of a regular polygon, this only works for regular polygons, is 1/2 the apothem times the perimeter. Okay, we usually just write 1/2 AP. Apothem, again, is the distance from the center to the edge, this line right here. Perimeter being adding up all the sides. And then where does the 1/2 come from? Okay, it comes from the fact that originally we broke this thing into triangles and we were using that formula. Now, you just need to know how to apply that formula. Okay, so you would see questions like these. Find the area of a regular polygon. Now, for right now, we're going to give you the apothem. later on in the course, you might be solving for the apothem using trigonometry or Pythagorean theorem, something like that. Okay, so in this case, 1/2 apothem times perimeter. Okay, so we would do 1/2 apothem. Now they're just giving it to us as 7. Perimeter, okay, we would need to figure that out. So, but they give us one of the side lengths, so 8. And there are 1, 2, 3, 4, 5, 6 sides. So that's going to be 48 is the perimeter. Okay, so a lot of students will accidentally plug in 8, but you don't want just one side, you want all the sides. Okay, so we get 48, and now we simplify. That'll give me 24 times 7, right, which is 140 plus 28, which is 168. And then we need a unit. Okay, we're talking about area, so inches squared. And now you're done. Okay, if you want to try the other one, feel free to pause the video and give that a go. Okay, so we'll do area equals 1/2 apothem, which is just given to you. Perimeter, I'd have to count up the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's a decagon. So we'll do 8 times 10 is 80 for the perimeter. Okay, so we get, I'll just get a calculator real quick, 40 times 12.3. Okay, we end up with 492 inches squared. And that's today's lesson. Okay, so if you look on Canvas, you will see Unit 3, Lesson 4. The assignment will be some questions related to these concepts that we just learned. It will also be some questions about what we learned last week in Lessons 1 and 2. If you have any questions or you're not sure about something, please feel free to send me an email anytime. Otherwise, have a great day.